Hi, in this video we will learn the mathematical model of Adaboost. So what is Adaboost? Adaboost is an algorithm for constructing a strong classifier as linear combination of simple weak classifiers Km. Learning in Adaboost is done in iterations. At iteration m, a weak learner Km is selected and a coefficient alpha m is assigned to that weak learner. This coefficient alpha m is nothing but the weight that is assigned to that weak learner. At each iteration m, weight is also assigned to each training sample in Adaboost. Let Wim is the weight assigned to ith sample at iteration m. Then Wim is given by this equation. In this equation, E is some error function which can be mean squared error or exponential error or some other error function. And Xi is the ith training sample. And Fm-1 is our trained model after m-1 iterations. Let's see the derivation. So we have a training set consisting of xi, yi's for I goes from 1 to n. Here, yi is the true Boolean target concept which we want to learn, and yi can take values only -1 or +1. Ki's for I goes from 1 to L are the set of weak classifiers. At each iteration, a weak classifier will be selected from this set, and the classification given by such a classifier for any instance x will also be just -1 or +1. After m-1 iterations, the classification of ith training sample is given by summing all the alpha i's and ki's for I goes from 1 to n, m-1. After m iterations, the classification again of ith training sample is given by just adding the previous classifications by the m-1 iterations plus alpha m and km xi. Now the question is, what should be the best choice for km and what should be its weight alpha m? Now let's see how the weak classifier km is selected at iteration m. Let E be the sum of exponential loss of Cm on each training data point. The reason we have chosen exponential loss here is because exponential error function grows exponentially for misclassified example, due to which the error term will have more weightage for the misclassified samples than the classified samples. The E is given by this particular equation. The total sum of exponential loss is given by this particular equation. Summation I goes from 1 to n. Here, n is the total number of training examples and e raised to the power minus yi cmxi. Yi is the true classification of ith training sample xi and cmxi is the classification given by the mth boosted classifier. Now on substituting cmxi as cm-1 xi plus alpha m km xi, we get this equation for the error function e. Now in this equation, the term e raised to the power minus yi cm-1 xi is nothing but the weight assigned to ith training sample at iteration m. So replacing this by Wim, we get this equation. That is, the error function e for the total error at iteration m is given by Wim multiplied by e raised to the power minus yi alpha m km xi. Here, yi is the true classification of ith training sample and km xi is the classification of ith training sample xi given by the selected weak classifier km. Now, when yi is equal to km xi, then this term will be reduced to Wim e raised to the power minus alpha m. we can see this term here when yi is equal to kmxi, wim e raised to the power minus alpha m. Similarly, when yi is not equal to kmxi, that is, the classification given by the selected V classifier is not correct, then we get this term wim e raised to the power alpha m. On further simplifying this equation, we get this equation. Now in this equation we can see clearly that the only term that is dependent on km, the V classifier, is this particular term, summation wim yi is not equal to kmxi. So only this particular term depends on km in the error function equation. So from this we can deduce that km that minimizes e, the total error, is the one that minimizes this particular term. But this particular term is nothing but the total weighted error for the classifier km. So we can conclude that the classifier which is chosen at iteration m is the one that minimizes the total weighted error at iteration m. So km is the V classifier with lowest weighted error. Now we will find out the answer for the next question, that is what should be the value of alpha m for this particular V classifier km. To calculate alpha m, we want alpha m so that the total error e is minimized. To do that, we will differentiate e with respect to alpha m. On substituting e by the corresponding equation for e and differentiating this equation by alpha m, we get this equation. Now to minimize it, we will equate it to 0. On equating it to 0, we get the final value of alpha m as this equation. Now to simplify this equation further, we will calculate one extra term which will be the error rate for the V classifier km. Let epsilon m be the weighted error rate of V classifier km. That is, epsilon m is given by summation of all the samples weight which are misclassified by the selected V classifier km divided by the sum of all training samples weight. On using this epsilon m in the equation of alpha m, we will get the new equation for alpha m, which is this. That is, alpha m is 0.5 natural log 1 minus epsilon m by divided by epsilon m. So to summarize the final algorithm of Adaboost, learning in Adaboost will happen in iterations. At iteration m, a weak classifier is chosen from a set of weak classifiers that minimizes the total weighted error, which is given by this equation. After selecting the V classifier km, we calculate the error rate for this particular V classifier, which is given by epsilon m. Using this epsilon m, we calculate the value of alpha m. Using this alpha m and km, we improve the boosted classifier cm-1 to cm. cmxi is given by cm-1xi plus alpha m kmxi. As an assignment, find out how many iterations are required for optimal learning in Adaboost. Now we will see the implementation of Adaboost. Thank you.